Dual purpose farm pond for water harvesting and groundwater recharge in Punjab Shivaliks. Shivalik Himalayas are one of the 8 most fragile ecosystem where soil loss of more than 80 tons per hectare per year have been reported. These Shivalik Himalayas are in states of Himachal Pradesh, Haryana, Punjab and Jammu, part of J&K Union Territory. The food bowl of India, Punjab has 10% of its geographical area under Shivalik Himalayas and rest 90% is in plain and lies just below hills. Punjab Shivaliks have undulating topography, rain-fed agroecosystem, soils are gravelly, groundwater is deep, canal irrigation is not feasible and thus water harvesting is the only option for sustaining agriculture. Just lying below is Punjab Plains, which has a prevalent paddy wheat cycle, which is a water guzzling system. Central Groundwater Board 2017 report reveals that 84% of the blocks are overexploited due to groundwater extraction. The solution to both of the above problem is developing a technology which can harvest water and simultaneously recharge groundwater. A study was initiated with the financial aid of NABARD Punjab with the objective to develop a dual purpose farm pond which has a potential for water harvesting as well as groundwater recharge, and to develop a decision support system. A watershed having catchment area of 6 hectare in farmer field was selected in district SS Nagar, Punjab. The schematic view of the technology showing inlet, approach channel, water harvesting pond and structure for recharge of excess water overflowing from the pond is given. The major interventions while executing the plan were construction of approach channel, digging and lining of water harvesting pond, groundwater recharge structure and gauging station for measurement of runoff. An approach channel was constructed to channelize the water to the pond and to measure the water flowing from the catchment area. A pond of 538 cubic meter storage capacity was created, which was lined with 300 GSM silpoline sheet to check seepage as the soil of Shivaliks are gravelly. A recharge well of 2.5 meter deep and 3 meter in diameter was constructed. At the center of this well, a recharge shaft of 9-inch diameter and 10 meter length was inserted. The recharge well was covered to avoid exigencies. 3 gauging stations were constructed to measure runoff from the catchment area. One gauging station was constructed before the pond. Second gauging station was constructed after the pond, and the third after the recharge structure to assess the runoff water partitioning. This video shows the actual field conditions of the experiment. This is approach channel through which water flows from the catchment area, and this is the first gauging station where the runoff water flowing from the catchment area is measured. The runoff is measured through a float and the water enters into this chamber through this slit, and as per the level of the water, the float measures the height of the water, and accordingly through calculation the runoff volume is calculated. This is the pond, water enters into pond, and after the pond again the water is measured through the same system, the gauging station, and the excess water from this goes to the recharge well, and excess amount of water is again gauged which moves away from the recharge structure. In the gauging stations, this type of charts are prepared which shows the runoff water flow which is being depicted through the peaks. Event-wise runoff observed and runoff volume passing from each gauging station was worked out from the charts which were obtained from the gauging station as has been shown previously. Impacts of dual purpose farm pond technology. Water availability. The technology created 548 cubic meter of water storage, which is equivalent to 548,000 liters of water, and is sufficient to give one irrigation of 5 centimeter to about 2.5 acres of land. Flood control and resource protection. Before the implementation of the technology, the downstream field of the farmer were getting damaged every year during heavy rains. However, after implementation of the technology, even at 130 mm rainfall received on 27 July 2021, it did not impacted the lower lying field. Hence, such dual purpose farm pond can help mitigate devastation due to floods in downstream area of forest catchments. Additional livelihood security. The farmer can now rear fish in the pond. In present case, farmer had stocked 6,000 seedlings of rohu and katla species in pond and is giving fish meal to the fishes. Such activity would surely increase the livelihood security through income diversification. Groundwater recharge. The recharge pit which was created can help in recharging the groundwater. Punjab is facing acute groundwater storage. The project demonstrates the feasibility of achieving dual purpose of water harvesting and recharging the groundwater through excess runoff water. Such farm ponds, if constructed in different locations, would certainly help in substantially recharging groundwater in Punjab. On the basis of the experience and other studies carried out in the region by the Institute, a decision support system for runoff estimation, farm pond designing and groundwater recharge structure was prepared. The software is available on the following link and also on the Institute website. The software is having a copyright of the Institute which was provided in 2024. The software has a capability of calculating the runoff volume, water requirement in command area, design of the pond, designing of inlet and outlet of the pond, and designing of the recharge pit. A help manual is also provided in the software. Thank you very much. The detail of the technology can be obtained from Director, Indian Institute of Soil and Water Conservation, Dehradun, or Head, Indian Institute of Soil and Water Conservation Research Center, Chandigarh. Thank you very much.